for cloud data engineers or data engineering leads, or the position is related to data, and they have asked the 5 interview questions. So I'm going through each one of them, and so 4 are the more on working experience, and the 5th one was coding experience. So let's go through this one. In the first question, how would you design scalable batch streaming data pipelines? Okay, so let's go through here. This is the system, and this is source system, and we need to get the data real time and batch as well as. So how do we design? So this is RDS. I go through and then use some kind of real-time batch division kind of tool, CTC plus Kafka, and then here we have all the data, right? So we have all the data. So, and we are going to process this data. One way is use Spark streaming and do so many things, right? Other way is I'm going through like this way, reverse approach. I'm going through like use Flink, and then from Kafka to everyday sync, use batch job for Airflow or something to schedule and store data into Delta Lake. So this is what approach I was thinking in my. I'm from Flink to here to here. There is 2 approach. So here to this also Delta Lake kind of things. It can use Azure and AWS, and here we can, I'm thinking kind of HBase or something, high performance engine, and then there should be some mechanism to merge here for daily and weekly data, and then here we have reporting kind of Grafana or something if we need real time, otherwise Power BI or something. So this is what system I'm thinking. Please, so previously I prepared some notes, so let me see those notes. So there is a 4 to 5 way process data injection. Here I use Kafka, Azure Event Hubs, and AWS Kinesis. So this is everything is same, right? So you consider Kafka, database, replica, SFTP, API pooling for batch polling. Storage we use Kafka. For batch processing use direct query mode, and hybrid we can think about division plus Kafka. The second step, right? Data processing. For scheduling, Airflow is must. Incremental DBT and batch. For batch, Spark, Databricks. Streaming, as I said. Storage, we can use Delta Lakes. And for row storage, S3, ADLC, Kafka. Stores unprocessed data. Optimize, we use Delta Lakes. Optimize for analytics. Serving layer, we use for BI dashboard, Snowflake, Synapse. I mean, we can directly query from Databricks, but we can use Snowflake and Synapse, which is very quite. Orchestration, we can use Airflow, DBT, and Terraform as infrastructure as a code. Okay, batch, Apache. So this is high level, like whatever I say, it is same, but this is in more detail. So I'm going to give this link to my in video. So let's wrap it. The second question is second question is now the second question, and they ask how do you make sure exactly once in Kafka, and this is what I need your guys thoughts, and how do you ensure that exactly. So before going through this one, as you know, the Kafka architecture, right, it's very simple, and this is producer I call P, this is Kafka, and Kafka have various nodes which call the brokers, and here is consumer. So now they want here exactly once, make sure in Kafka doesn't have duplicates. So there is a 2-3 process in the market, right, and which we are going to talk about. The first one is they call the transaction sum system, and I'm not able to pronounce, but it's the name like something. So let's go through here. I created a very big tutorial here. So this is what Kafka producer, Kafka cluster, Kafka consumer, so Kafka core architecture, and it's very detailed. So basically, so think it like Kafka topic, you get a Kafka topic. So have a three partition. Let's say partition 01. So message will always go sequentially. Message 1, 2, 3, then 2, 3, 4, 5, 6, 7, 7. So this is the message ID generate for each record. So if anything is missing or anything come duplicate, they will know. So every partition have a leader broker 1, leader broker 2, leader broker 3. So each partition is order immutable sequence, has a unique offset for each record. It replicates across multiple broker and for fault tolerance. It has a leader broker and multiple follower broker. Message flow, message will go round robin. The message sent to leader broker in partition. The leader write message to local logs and follower took this message and replicate it. Once replica have copy a message and config min sync replica write to minimum sync exactly once. So this is very which is they ask, right? So this is important. Kafka 0.11 feature called idempotent procedure and transaction message. So I will call idempotent and transaction. Using this one, they will make sure exactly once. So what this procedure we need this enable equal to true, right? This is automatically sets acknowledge equal to all retry integer max value. So this is what we need to do. True. So producer ID, PID, unique ID for each producer. Sequence number, monotically increase number PID, partition, topic partition. The broker maintain last sequence number seen for each PID. Any gap sequence number indicate potentially duplicates, right? For transaction message, transaction allow atomic write across multiple partition. So they do commit, right? Commit transaction. Internal mechanism to exactly one. So producer side guarantee, producer maintain the in-memory map. When the sending message, they will store inside the map. Broker side also, broker also maintain two key data structure. When message arrives, check if the sequence number is last sequence greater than 0. If yes, then accept. Update last sequence. If no, either reject the sequence number or ignore sequence number. This is how they do so Kafka. So basically in high level, there are two processes which handle these things, but you need to give very detailed answer. So I'm not going to this one. Okay, and now the next question is very important. What happened if an Apache Spark jobs run out of memory? What happened, right? So if you guys know, this is Apache Spark, and what happened? What happened? This is out of memory, right? So it will fail, of course. It might fail. It might retry, and there is what else it can do? And so there is various way to fail, like it's broker fails, I mean not broker, it's a executor fails or driver fails. Driver cannot fail, mostly like executor memory related. So there is various memory issue can happen, right? So we are going through this one. Let me talk about this one. Okay, so what happened if Apache Spark job run out of memory? So basically it will have four things. It will have four things. Job fail out of memory. Executor death, task retry but may fail again. Excessive disk is failing. So it will happen three things. Now, so when can Spark run out of memory? So when driver memory. So when you're collecting on driver, collect all the data will come into driver. So in driver you cannot fit that data, then it will fail. Executor memory, insufficient memory for computation tasks. Shuffle memory, large data transfer across various join aggregation, exclusive broadcast memory, large broadcast. Okay, so what happened is for okay, so out of memory error, this is the reason the smart driver or executor does not have enough space. Shuffle is split. The reason is Spark spill intermediate data disks due to insufficient memory. Executor loss, get track and retry loop. Increase memory. So how do you fix increase memory? Optimize data transformation. Tune the Spark memory configuration. Fraction equal to right 0.01. Enable data serialization. So this one they said this will reduce about 30% to 50%. Serialization is always important. And use data frame instead of RDT because each object separately in memory, but data frames are optimized columnar. Okay, so this is how it will. Now the next question, explain how Databricks handle delta logs. So this one you need to go through, understand first how is delta file format, right? So I'm going high level. Let's see. So let's what happened if Databricks fail. I mean, explain delta logs in Databricks. So how do you explain? So basically, delta logs supports, if you know about delta file format, is about ACID. It's about time travel. Means you can have it support delete, insert, and it's very optimized. So this property it will happen. But how behind the scene it will do? Let's go through it. So delta lake, as I said, ACID, schema, versioning, efficient upserts. How delta lake store data? So how they will store? Actually, it's stored in Parquet file. And they also maintain transaction log, which is called delta log. Store metadata about each transaction in JSON Parquet. About each transaction. Track, insert, update, delete. Enable time travel, rollback. So this is how my file, they have Parquet file. Each time they create new Parquet and maintain all the logs metadata for first commit, track changes in metadata. New write, append Parquet file or update delta log. Delete write new Parquet file. So new write, they will append Parquet file, or delete update, then write a new Parquet file, mark as old one is deleted. Okay, so this is time travel and so on. So basically, yeah, this is how you need to store format, store data in Parquet, track changes in the delta log. ACID transaction ensures the consistency using atomicity. Time travel, query old version, upset delete, use margin to schema evolution, support automatic schema changes. Performance optimization, you can use G-order optimized for faster query, right? And now the live coding, there was a live coding and they asked me, how do you, okay, so I have 10 GB file, okay, and this 10 GB file, I need to put data into data warehouse. How do I do? So this one can be in local system, this one can be in another system or read from file. Okay, so one way for the small file, what I think I use pandas and chunk size, pandas and chunk size, right? Read this chunk size and put it into like data warehousing. Read like every time read 1000 record or 10,000 records, which be better 10,000 divided by like this is 10 GB, so let's say 1 million, something like that. Otherwise, use the Spark and directly transfer data into Parquet. So let's go through it, right? So this is the program which I did. Reading this file, then chunk size is 10,000 and read CSV chunk size, and here directly I am appending. If exist, then append, otherwise it's create. There is no index because it's very fast, right? The other way is use read large CSV file in distributed manner, okay, and then overwrite into Parquet file, or otherwise optional into we can load into database also. Okay, so the high level small file we can use limited by this pandas plus chunking, PySpark data EMR also use. So this is what the second round for cloud data engineers, and I'm going through